Let's see the question. An ideal gas is expanding according to the relation P square equal to constant, where P pressure, T temperature. What is the coefficient of volume expansion of the gas? This is the previous year's question of IIT 2008. Let's see the theory. We know the coefficient of volume expansion is basically represented by the symbol gamma. We all know that gamma is also used to represent the ratio of two specific heat, that means Cp and Cv. But here we'll talk about coefficient of volume expansion. Before starting, we should know what is coefficient of volume expansion. Actually, we all know it almost from class 9. Let at temperature T1, the original volume of an object is V1. After giving some amount of heat, its temperature become T2 and then its volume become V2. So definitely T2 greater than T1 and volume V2 is greater than V1. So what is the formula of expansion of volume? We know that the expansion of volume V2 minus V1, it is basically represent the expansion of volume. So this V2 minus V1 is directly proportional to original volume, as well as V2 minus V1 is directly proportional to the temperature difference. Now together we can write V2 minus V1 is proportional to V1 into T2 minus T1. So we can write V2 minus V1 equal to constant. We will use gamma here, V1 delta T. We will use delta T for T2 minus T1 because T2 minus T1 is temperature difference. That is why we will use delta T. And gamma is the constant here. Gamma is basically known as the coefficient of volume expansion. Now we can write gamma equal to V2 minus V1 divided by V1 delta T. So V2 minus V1 we can write delta V divided by V1 delta T. So now we can also write, just see this thing carefully, we can also write gamma is equal to 1 by V dV by dt. This is the formula we will use in thermodynamics to represent the coefficient of volume expansion, where V is the volume of the object and dV is basically, dV or delta V is basically change in volume, dt or delta T is basically change in temperature. For simplicity, I'll write there gamma equal to 1 by V dV by dt. Okay, we'll use this formula. Now, the question was an ideal gas is expanding according to the relation Pt square equal to constant. So the relation is Pt square equal to constant. But we have to find gamma. For gamma, we need dV by dt. But no pressure is there. So we have to substitute this pressure. For ideal gas, for 1 mole ideal gas, let we know PV equal to RT. So P equal to RT by V. We will use that P in this equation. So that equation looks like that. So it will be R V inverse T cube equal to constant. Now we can write T cube by V equal to constant because R is also constant. Now differentiating both sides with respect to T. Differentiating both sides with respect to temperature T. So what will be the result? d dt T cube by V equal to 0 because in the right side constant is there. So now using the well-known formula V square V d dt T cube minus T cube d dt V, that will be 0. Now what will be the result? V is there and differentiating T cube, this result will be 3T square minus T cube dV dt divided by V square equal to 0. So the result will be 3VT square minus T cube dV dt is equal to 0. So we can do 3VT square is equal to T cube dV by dt. So now we can write 3V T square and T cube, they will cancel each other. T will be there. T dV by dt. So the result will be 3 by T equal to 1 by V dV by dt. And we all know 1 by V dV by dt is basically gamma. So we can write this is gamma directly. So what is the coefficient of volume expansion of the gas here? That is 3 by T. Just see it carefully. From this term we can write this, and the final result of coefficient of volume expansion of the gas will be 3 by T. This is the final answer. Now we will solve few more numericals. The question is, an ideal gas is found to obey the relation PV to the power n equal to constant during adiabatic process. The coefficient of volume expansion of the gas, these are the options. So you have to remember that n is also constant here. The relation is PV to the power n equal to constant, and we all know we have to find gamma, coefficient of volume expansion, that is 1 by V dV by dt, that we have to find. Now for ideal gas, we know PV equal to RT for 1 mole gas. So P will be RT by V. So we can write, instead of P, RT by V, and that will be V to the power n equal to constant. So now we can write RT V to the power n minus 1 equal to constant. So that will be T V to the power n minus 1 equal to constant, because R is also constant. Now differentiating both sides with respect to T, the result will be that right side will be 0 because the right side is constant. So now T d dt V to the power n minus 1 plus V to the power n minus 1 d dt into T is equal to 0. Now T n minus 1 V to the power n minus 1 into dv dt plus V to the power n minus 1 equal to 0, because dt dt will be 1. So that in that term, T n minus 1 V to the power n minus 1 into V to the power minus 1 dv dt we can write by using the law of indices, and that will be minus V to the power n minus 1. So that term we can cancel. So it will be T n minus 1 divided by V dv dt is equal to minus 1. Now we can write from that dv by dt is equal to minus V by T into n minus 1. The gamma value will be 1 by V dv by dt. So 1 by V, instead of dv by dt we can write minus V by T into n minus 1 T into n minus 1. So what we can write, V will cancel each other, minus 1 by T into n minus 1. So if we take minus common, then minus T into 1 minus n, minus minus will cancel each other. Gamma will be 1 by T, 1 minus n. I think option B is the right answer. For board exam, this question is quite important. The question is, for an ideal gas, density rho, mass m and volume V are related as rho equal to m by V. We all know, sir. Now show that at temperature T, its coefficient of volume expansion will be equal to minus 1 by rho d rho by dt. So try it by yourself.